Welcome to the Deep Dive. Today we're looking at something really fascinating, sparked by a source one of you shared.
Oh yeah? What's the topic?
It's called The Illusion of Lookback Time, Why JWST Sees the Same Galaxies. It's by Dave Champagne and 01, using ChatGPT apparently.
Interesting title. James Webb Space Telescope findings, then.
Exactly. It questions what we're really seeing in those deep space images. So our mission today is basically to unpack this alternative view on light and time.
Okay, an alternative to look-back time. Sounds like a proper deep dive. Let's get into it.
Right. So maybe start with the standard view. What is look-back time traditionally?
Sure. The conventional idea is pretty straightforward, really. Light travels incredibly fast, but space is vast. So light from very distant galaxies takes billions of years to reach us.
Meaning we see them not as they are now, but as they were billions of years ago.
Precisely. Like cosmic history snapshots, we look far away, we look back in time. That's the essence of look-back time.
Okay, so Hubble showed us distant galaxies, and we thought, okay, that's the young universe.
Exactly. And the expectation for JWST, with its, much more powerful infrared capabilities, was that it would push even further back.
To see the really early stuff, like the very first galaxies forming.
Yeah, the so-called baby galaxies, or maybe just primitive blobs of gas, the really primordial structures.
That's not quite what happened, is it? That's the core of this source's argument.
Well, that's the puzzle, isn't it? JWST is seeing incredibly distant objects, and they are much clearer, much sharper than Hubble could manage. But
they look familiar.
Surprisingly so, yes. They often look quite structured, more mature than many expected for that supposed early era. Not just chaotic primordial clouds. Sharper, yes, but not necessarily younger looking in the way predicted.
Right. So if look-back time suggests we should be seeing baby galaxies, but we're seeing these surprisingly mature ones,
Yeah.
what's the alternative explanation from this motion theory?
Okay, so motion theory, as presented in the source, takes a very different path. It starts by questioning the very nature of light.
Not photons traveling through space.
Kind of, yeah. It redefines things through motion and structured motion. Instead of seeing light as particles, photons making a long journey, it proposes light is more like a rhythmic pattern.
A pattern, like ripples on a pond.
Something like that. A rhythmic compression pattern emitted by massive objects. And crucially, this structured motion, as they call it, doesn't travel in the way a particle does. It sort of shapes the medium, or shapes the motion itself.
Shapes the motion itself. Okay, that's a bit abstract. How does detection work then? How does JWST see anything?
This is key. Detection isn't about catching an old photon that's finished its journey. Motion theory calls it real-time resolution.
Real-time.
Yeah. The idea is, if you have a detector like JWST that's sensitive enough, or tuned correctly, it can resolve this structured motion locally. If the rhythm, the pattern is stable and present, the detector finalizes the structure right here, right now.
So wait, no travel time, no delay. If the structure is stable out there, a good enough telescope resolves it instantly here.
That's the implication. No billions of years of transit time involved in the detection itself. It's about syncing with an existing, stable structure. Think of tuning a radio, you get the broadcast now, not an echo from when it was first transmitted.
Okay, I think I'm starting to grasp it. So if this motion theory is right, JWST seeing mature-looking galaxies isn't a paradox.
Exactly. It's just seeing the current state of those distant, stable structures with unprecedented clarity. Better optics mean better resolution of what is, not a deeper look into what was.
So the telescope's power gives us sharpness, not time travel.
That's the argument. We're sinking into the real-time structure of the universe, to use their kind of phrasing, not looking back across billions of years.
So the key takeaway here is you're not seeing what was, you're seeing what still is. Persistent structure, resolved in real time.
Yes. It replaces the idea of traveling photons with rhythm, resolution, and presence. It's a fundamentally different way to think about observing the cosmos. Now, it's important to stress this is a radical departure from established physics and cosmology.
Absolutely. It's way outside the mainstream. But let's just follow the thought experiment. If look-back time is an illusion, as this source suggests, what does that even mean?
Well, the implications are pretty huge, aren't they? If we're seeing distant galaxies essentially as they are now, or at least their persistent structures in real time,
then our whole timeline of cosmic evolution based on those early galaxy snapshots needs rethinking.
it potentially could, yes. It might suggest a universe that's Perhaps more interconnected or dynamically stable across vast distances than our current models allow? Maybe cosmic evolution didn't proceed quite the way we thought if those distant galaxies aren't actually ancient.
Hmm. It forces you to question some really basic assumptions about space, time, and light. If look-back time isn't the whole story.
What else might we be misinterpreting? What other foundational ideas might need a second look? It certainly gives you pause.
It really does. Thinking those incredible JWST images might be showing us the present universe, just very far away. That's a mind-bending thought to end on. Definitely provocative.
Indeed. A lot to mull over there.